Welcome to episode 104 of my Dissect and Member, My Scattered Thoughts. However, I am going to begin now a series, I'm not sure how long it's going to last, of connected thoughts. Because I want to speak about something which is not directly spiritual. In fact, ultimately, it's not spiritual at all, but is in the minds of many and has been talked about today in many different flavors and terms and ways of expression. Is called artificial intelligence. And of course, one question is it really intelligence? It's artificial, that is to say, it's made by man, but is it intelligent? I'm going to give you the conceptual understanding of what it is. I'm going to simplify enormously, but it will not be oversimplification. I want to make it clear just what the components are out of which artificial intelligence arises. And I'm not sure how long it's going to take. I'm going to break it up into smaller segments. Just so you know in advance, there's 4 different stages in the creation and use of artificial intelligence. One is called pre-training, one is called training, one is called post-training, and one is called reinforcement training. And once you've gone through those 4 stages, you've got an intelligent, artificial intelligence program or app. So let's start out. The very first point I want to make is that artificial intelligence is something which requires a computer. It can't be done with an abacus. You can't do it with water clocks. You have to have a computer. And what exactly is a computer in the most basic understanding of it? A computer is a device which we create to process information. And it operates in every case in this way. You've got this device, you've got to input something in that device. It begins empty. What you input has to be translated into some form that a machine can recognize. Then it's got to be stored. It's got to be in the machine somewhere, in the device. And then you operate on it, you manipulate it, you process it. And by the way, that's where we get the CPU from, Central Processing Unit. That's the heart of the computer that does the processing. Once you process it, you got a result, and you store the result, and then you have to translate that result from what the machine can recognize to what we can understand and then display it or output it. So that's what a computer does. Let's give a very basic example. Let me tell you, there is no computer program which does not follow this example, this process. It may be far more complicated. It will be far more complicated, much more complex, much more difficult to understand, but it does not deviate from this process. Let us take using a computer with a keypad on it to multiply 2 times 2, or let's just add 2 times 2 and get 4. So what do? You've got this device in front of you, and there's a keyboard on it, and one of those keys has the number 2, and we recognize, oh, that's the number 2. Let's push that. Well, that is going to be stored in the computer, but the computer doesn't know what a 2 is. We have to make that 2 correspond to something. And so we put it into digital language, binary language, not decimal like our numbers we're used to. And so the number 2 is really, for the most part, electrons, a 0, a 1, and a 0. Okay, where's that one? What do you mean? Where is that? How do you put a 0 in a machine? You have what's called transistors. What are transistors? Transistors are little elements of matter that can accept electrons and have a charge, because electrons give you a charge, electrical charge, or they can be discharged and have no electrons. Very few. So each transistor either has a lot of electrons in there, it's charged, or very few, it's effectively not charged. And we say, okay, we're going to call a charged transistor a 1. And we're going to call an uncharged transistor a 0. And we can make it, we can charge or discharge it at our will. So now we take the number 2, which we understand what that means, and we press a button, which has a 2 on it, so we know what it is, and that goes and it stores in the computer transistors a charged transistor, which is a 1, and an uncharged transistor, which is a 0. That's it. That's what a 2 is inside a computer. Now, you hit a button, it's got a plus sign on it. We know what that means. That means addition. It means taking one thing and adding it to another. So we hit that button. The computer doesn't know what addition means. We have to have a corresponding number for that. Let's just say it's 1111. I don't know what it is. It's some binary number. But now that gets stored in the computer. And now we hit the 2 button again, and the computer, okay, I'll put another 10 in there. So now we have these transistors that are charged, uncharged, charged, 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 uncharged. We got 2, add 2. We hit the equal button. We know what that means. It means I want to perform an operation now. I want to get the result. And so we put that also has to be translated. It's an input. It translated into a number, a binary number. Let's call it 1010. That goes into 4 transistors. And now the computer has stored 2 sets of data and 2 operations. And when you finally hit that equal sign, that's the signal of the computer, do what I told you. And what does the computer do? Mathematically or electronically, it adds a 1 and a 0 to a 1 and a 0, and that ends up in binary language 100, which we call 4. And so now the computer stores 100. That doesn't help us. We can't measure electronic currents with our fingers, you know? Well, enough of it we can. We get shocked. But so what does it do? It now translates that 100, let's say, onto a display with pixels in there in the shape of a 4, and we say 4. So we've gone 2 plus 2 equals 4. We understand that. Does the machine understand that? No, the machine doesn't understand that. We created the machine. We created it in such a way that it would take our input and translate it into electronic binary form, and it would operate on it in a way that we specified by the circuits in that device. And it would give a result, which would then translate and show to us. So that's what computers do. All computers do that. And computers don't know what they're doing. We enter the data, we give the instructions, we read the results. I think I'll call it for that. That's enough for one. We're going to go on to what AI is, but just so you know, AI, artificial intelligence, is a very complex program that runs on very fast, very extensive computers, thousands and thousands of CPUs, terabytes and petabytes of storage space, but it all is qualitatively the same as adding 2 plus 2 on a computer.